Everyone, and welcome back to PA Academy. So this is the example 2 on our video series on Newton-Raphson iteration, which is one of the ways of solving nonlinear equations. All right. So if you missed the previous part, the example 1 of this video and the introductory part, kindly watch the video before this, and then you're going to get that. All right. So before we start example 2, if you are still yet to subscribe, please go ahead right now, click on that subscribe button and also the bell icon so that you can get notified of future videos. All right, so go ahead right now, just click on that subscribe button. So we'll just give you 1 second and 2 seconds to do that. All right, so thank you very much if you have just done that. So now let's go ahead and look at the solution to this example here. The example says, use the Newton-Raphson, that's the meaning of this NR, okay, Newton-Raphson iteration to find a solution of the nonlinear equation 3 raised to the power x plus 4x equals to 5x, starting from x naught equals to 2. All right, so again, don't forget the general representation, or should I call this equation, which is x of n plus 1 equals to xn minus f into bracket xn over f prime of xn. Okay, all right, so now let's write so from it, this is it right here. So that will be 3 raised to the power x plus 4 raised to the power x. Then, this one, we bring it to the other side of the equals to sign, become minus 5 raised to the power x. All right, now for the f prime of x, so that means if you have to differentiate the f of x, all right, for this 3 raised to the power x is going to be 3 raised to the power x ln 3 plus 4 raised to the power x ln 4 minus 5 raised to the power x ln 5. Now you might be wondering how that was come about. So you just need to take note that dy over dx in that nature, okay, so when you have a raised to the power x is a raised to the power x ln a. All right, so that is what is playing out right here. Okay, so now we already have the two values, so let's go ahead and bring in our the equation. All right, so that will be xn plus 1 is equals to xn minus, so 3 raised to the power x plus 4 raised to the power x minus 5 raised to the power x over, so this is going to be 3x ln 3. So basically what we are having here is, maybe I should just write out the equation on the side again, so that just in case you didn't watch the first part of the video, so that will be x plus 1 is equals to xn minus f of x over f prime of xn. Okay, so what's happening here is we are having f of x over f prime of x. Okay, so plus 4x ln 4 minus 5x ln 5. Okay, so now let's go ahead and start the iteration process. So for first iteration, we are going to be having our x1 equals to x naught minus, and don't forget we are told that our x naught is 2. Okay, so it's going to be 3 raised to the power x plus 4 raised to the power x minus 5 raised to the power x over 3 raised to the power x ln 3 plus 4 raised to the power x ln 4 minus 5 raised to the power x ln 5. Okay, so guys, if you are finding value, please give the video a thumbs up. Now let's substitute the value of our s naught. The question already told us that starting from x naught equals to 2. So let me show you. So you can see our x naught equals to 2. So let's replace it where necessary. So with that, our x1 is equals to 2 minus 3 raised to the power 2 plus 4 raised to the power 2 minus 5 raised to the power 2 over 3 square ln 3 plus 4 square ln 4 minus 5 square ln 5. Sorry, 5 raised to the power 2 ln 5. Okay, now if you should do the numerator where we are having, Okay, here we are having 3 raised to the power 2 right here, right? So that's going to be 9 plus 4 raised to the power 2 is 16, then minus 5 raised to the power 2, that's 25. You know, this will give us a 0, all right? And 0 over any number, whatever the number is, will also give us a 0, okay? So with that, we are going to be having 2 minus a 0, because this right here is already giving us a 0. So irrespective of what we have in the denominator, as long as you're having 0 as the numerator, it's still going to give us a 0. So that's why we are having 2 minus 0. And with that, our x1 is equals to 2. And with this, now, we can conclude that our x is equals to 2 is the solution. And we are not going to be doing any other iteration, because if you look closely, our x naught is 2. Okay, you can see from the question, our next x naught is given to be 2, and that now we are calculating and we are getting our x1 also to be 2. So that means even if you continue for x3, you still get 2. If you do for x4, you're still going to get 2. So this is where you're going to stop, and that's the solution that we are looking for. All right, so that is it on Newton-Raphson iteration involving one variable. In the next part of the video, we are going to be looking at the Newton-Raphson iteration involving 2 and 3 variables. All right, so thank you very much for watching, and if you have any question, like I do say, do let me know in the comment section, and then I'll do my best to attend to it. So my name is Prosper, and I'll see you all in the next part of this video. So let's go ahead to the next part, Newton-Raphson iteration involving 2, 3 variables like that.